Hi everyone, this is GKCS. In this video, we'll be talking about how tech runs in a startup. If you're running a small organization or working in a startup or small organization, you should find this video extremely useful. If you're working in a large organization, then some of the principles that are being spoken of here will be very relevant to your engineering or product managers. I'll be taking a war story which can help us understand how a typical startup works. This is specific to InterviewReady, which is a edtech startup, but most of these learnings can be generalized and used in your own team or organization. So let's go back to 2019, September. This is roughly 4 years ago, and I was working as a software engineer at Uber, but I also had this side hustle or passion of teaching computer algorithms and system design on YouTube. Eventually, the channel became large enough for me to decide that this passion of creating videos and making them as concise as possible and easily consumable and all that good stuff is something that I can make a company around. So the first thing you need to do to make this work is actually have a website. And a website is nothing but a namespace. Like InterviewReady is a namespace. You can purchase it, you can rent it out from people who host namespaces. So you can think of people having addresses all around India and someone having a registry of everybody's address. So Yellow Pages or Google. If I want to connect to a person, I have to go and read this book. Now, one thing you can do is you can charge me every time I read the book, but people don't like that. So instead, the person pays to have their address hosted in the book. InterviewReady goes and pays somebody, a company, so that users can find them in this book. Very similar to how Yellow Pages used to do things. And my company's name was InterviewReady.io. That got registered on GoDaddy. And then what happens is if anyone types on their browser InterviewReady, then GoDaddy says, oh, I know who you're trying to connect to. Here's an IP address which actually hosts InterviewReady. So that IP address is of course provided by me. I say that if someone is trying to connect to InterviewReady, just hit them on this IP address. Now that's the easy part. What should that IP address be hosting? Our server, something which can be spoken to. You can fire HTTP requests on the server and get some responses. And also there needs to be web pages that people can see on their browser. So who's going to do all that? Now I could create web pages and host them. I could also have my own server, local server and host it, but that would be madness. Or I should say that would be reinventing the wheel, which AWS or Azure or GCP have already made. The crazy thing is, I don't even need to host my server on AWS. I can take this entire problem of hosting videos, login and log out and payments and go to a known solution provider. And these solutions were being provided off the shelf by a company called Thinkific. They would charge you a particular commission for every person who would sign into your website. And I think there was something else also. There was a base rate that they would charge, but it was much lesser than me going and hosting an entire website because I'm alone at that time. It's a one-person company. Hosting courses then was managed by a server in Thinkific. People would connect to this server because the DNS pointed over there. And for static pages, which are website pages, there was a CDN again managed by Thinkific, which people could connect to and download the web page. So all the static images and text content can be picked up from here. All the dynamic content of login or writing comments would be handled in the server, which would be backed by a database surely. Now, this led to serious problems. I should say good things also before I start with the problems. The good things here, of course, were that I had to manage very few things. I didn't need to manage servers. I didn't need to manage video hosting. I didn't need to manage web pages. And I didn't need to manage payments. Support to some extent was handled already. And many of the features that come up with a built website were there, some of which I was not using, but then they were there. I could expand into that. Now let me come to the problem. Firstly, payments was a real big issue. Thinkific supported only 2 types of payments, and PayPal was Indian, Stripe was an international payment. I couldn't change payment methods. If there were payment failures, I couldn't do anything about it. I would have to personally ask people to go and pay on my PayPal link. And this was a real big problem because many of the Indians who were coming, they didn't want to pay through PayPal. They wanted to pay through UPI or any other method, while the Americans who were coming in wanted to pay through PayPal. Okay, this might sound like, how is this a tech problem? Well, it's a problem which will take down your startup if you're not serious about it. Customers are not going to be interested in the tech at all. They are interested in watching the videos. So initially, this payments itself, the whole thing is a problem. The second part was that the website was absolutely horrendous. Okay, I am a backend engineer. I suck at design, and I'm even worse maybe at implementing the UI pages. But that doesn't mean that the customers have to suffer because of my incompetence. What I really needed to do was to make web pages responsive and good for incoming customers. And that meant that I would probably need to outsource this problem to a freelancer or hire someone full-time who would maintain a website. The initial approach was to actually hire a freelancer for about 1 month to redesign the website. So from this CDN hosting all web pages by Thinkific, we moved to our own CDN solution, which was AWS CloudFront. Okay, it was backed by S3, which is a file store, and we made our web pages there, which were far better, much more appealing for users. They were also a little mobile friendly. And the other thing we did is we took all server calls directly from Thinkific to our own server. Okay, we put our server in between. We said that if you ever need to make payments, we have Razorpay, PayPal, Stripe. Just register on our website, and once you've made a payment, we are going to be redirecting you to Thinkific to watch the videos. Okay, it was a seamless integration, and users would hardly come to know that there's something backing this website. But even this simple wrapper gave us a lot more control. We knew which users are coming on the website, they're dropping off, more payment solutions were provided. Our own CDN was hosting web pages so we could SEO on them more effectively. We could change web pages the way we wanted, and it gave us the confidence to say, why do we even need Thinkific when we have the engineering talent to actually build it ourselves? So then we set up a CICD solution, which is continuous integration, continuous deployment. The basic idea is that every time you write some piece of code, you want to actually test it on prod or staging before you work on the next feature. It's probably the most important part if you're thinking of anything tech in a startup. Constantly, when you're making changes, you want to see the changes happening and being rolled out to your customers. Okay, you don't want to make a deployment once in a month or twice in a month, because the changes then are very large, especially in a small, fast-moving organization. So if you set up CI/CD, this might be a Jenkins thing, might be through GitHub Actions, that's how we do it. Every time you merge something to your main branch, you're going to see changes on your website, which is absolutely perfect. Because of this, we were able to quickly move features out of Thinkific into our own platform. It gave us a lot of control, and we were more confident about writing more features now because we were starting to get practiced in tech. The next thing that came up was simplification. Why are there so many moving components in this system? Can't we just put them all together? The microservices and the databases we had around different things, different business requirements, payments, discussions, were all moved into one thing. There's a monolith now. And we entirely got rid of Thinkific. We just moved out all the features from Thinkific and added them to our current database. We also added a cache before crunching the entire architecture to make it much smaller, right? Our EC2 instance was, I think, medium or large. I think it was large, and large was like ridiculous. Like, you don't need that kind of scale with 15,000 users. I think at that time we had something like 3,000 users. So we decided to move to medium, and from medium we have actually, I think, moved to small now. So we have 15,000 paid users, and small works perfectly fine. There's no shame in saying that, oh, I need a small server. You can take it as a matter of pride that it's so optimized that you need a small server. And the second thing is we had this cache, which was also an external cache, and we decided to move this into the server itself. You don't need a Redis deployment. You don't need anything outside. You don't need Elasticsearch. You can have it in the database. Just keep crunching your architecture till it becomes simple to understand, and also everything is put in one place. The deployment cycles become easy. Bit of a hard lesson, but it was a worthwhile lesson for us looking back. Also, you don't need crazy tools. Like, there's a tool called PagerDuty. It makes a lot of sense for large organizations, but for a startup, if you have a problem, Slack should be enough. Interesting business use cases or even tech alerts can be sent on Slack. So maybe your instance is having more than 50% memory consumed. Send a Slack alert. Someone made a payment but record was not persistent in the DB. Send a Slack alert. Your team will be there. Somebody is going to look into it and solve the problem. The same idea was also applied in MailChimp. It's a marketing platform. We moved to Amazon SES. It was much cheaper. LogRocket was another solution. It was like pretty expensive. I think we were paying at one point almost 20 or 40,000 per month, and Clarity is just free. So now let's see how code is actually deployed and reaches end customers. The funny thing about this is that in large organizations, this process is so smooth that engineers are not even aware of what's going on in the behind the scenes. It's abstracted out, so when you merge something to the main branch, it just happens by magic. But we'll see what's under the magic right here. Firstly, you have a code repository. For us, it's GitHub. If you're writing front-end code on GitHub, we have a workflow file which pushes this code to S3. S3 is a file store. You can think of these as some cloud server storing your files in directories, and we have a directory for InterviewReady UI which actually takes these files, just replaces everything because we did a git pull. Now S3 is globally distributed, but it's not as fast as you would like it to be. It's not on the edge as much as you would like it to be. So what you need is a CDN or a content delivery network solution. These are servers which are distributed all across the world. If you're looking for some sort of static content, then these are really fast. They give you responses really fast. You might know about Akamai, but again, we are using mostly AWS technologies here. So from S3, we publish these pages to CloudFront. And CloudFront has a really weird URL. It's like d44.cloudfront.net. Nobody in the world world can remember such a complex URL. So of course you want a easily visitable page, and so your DNS server, the thing that we talked about earlier from GoDaddy, has to point to this CloudFront URL because that's where your web page is. So people who are going to InterviewReady.io are saying, give me a web page for InterviewReady.io. And what needs to happen then is the DNS needs to say, go to this CDN solution, you will get the web page. And again, because we are using primarily AWS technologies, we have moved from the GoDaddy DNS resolution to Route 53, which is a DNS solution provided by AWS. Important to note here is that the domain is still owned by GoDaddy. So I still have to go and tell GoDaddy that, hey, please point to Route 53, which is AWS. And Route 53 then says, okay, I know where InterviewReady.io is. It's in this CloudFront solution. This is how a person accesses the front end of InterviewReady, the UI pages. Similarly, when you're writing code for the backend, this is a separate repository, again hosted on GitHub. You have an event listener running on EC2. So an event listener, you can imagine it to be like an API endpoint. You make a request that, hey, there is some code change. And then this server says, okay, code change has been noted. I'll do a git pull. After you do a git pull, you of course restart the server and your job is done. It's as good as a deployment. You also need to go and tell the DNS again that if somebody is trying to access the server of InterviewReady, not the web pages, but the server trying to hit an API, then we have configured it such that it is api.interviewready.io / the service name and so on. api.interviewready.io needs to be an IP address, and that IP address has to be stored in Route 53. But to bring in some fault tolerance and to bring in some redirection in case you want to add more servers ever in a startup, what you can do is have some sort of a load balancer in front. We are using ELB, which is Elastic Load Balancer in Amazon. Again, all of these technologies, the things that you see in colorful boxes are all Amazon. Okay, the icons are also picked up from them. The basic idea is when a person tries to connect to api.interviewready.io, they'll go to the Route 53 server. That will tell them, please go to this load balancer, and the load balancer will say, all right, fine, go to the EC2 instance. So that explains how the front end and back end code is being deployed. Important to note is that as engineers, you don't really care about load balancers or the DNS. These things are done manually by the IT team. In a startup, that IT team is us, but every time you're writing code, you don't need to care about, hey, is the Elastic Load Balancer on or is Route 53 working? You just push code to the main branch, and the moment that happens, it's going to be hitting an action listener, is what they call it, on EC2, and you can assume that your code is deployed. Okay, now let's look at the entire request flow end to end of a person coming to a website. Initially, they type the URL on the browser, that goes to Route 53. Route 53 then says, okay, go and hit the CloudFront solution because that's where you'll get the web page. The web page in itself may have components or iframes that it's loading from Vimeo, that's loading from S3. S3 is the file store that we talked about. It doesn't just store web pages, it can also store any kind of PDF files, image files that you have, which you may want to share with the user. So this might be a profile image also. Also, you need some sort of integration with any kind of payment gateway that you're going to use. For example, Stripe, PayPal, Razorpay, they give you client-side code that you can load. In that sense, of course, there's a lot more complexity. There's Google Analytics that you want to bring in. You might have some SEO tags, and all of this complexity is wonderfully encapsulated by the front end, which loads different frames, loads different tags based on what you want. But at a high level, these are the pieces of technology which are there in the front end. Now coming to the back end, if you're performing some sort of action on the UI, let's say you're trying to log in, it needs you to go and hit an API on the back end. So first you go to Route 53, ask that, I'm trying to connect to api.interviewready.io. Route 53 says go and hit this load balancer. It knows where you're trying to connect to. The load balancer then takes this request, forwards it to the EC2 instance that we have. EC2 then may or may not hit the database. Okay, we also have an in-memory cache, like we said earlier. We don't have a global cache Redis, and this RDS instance is managed by AWS. So we are using Postgres here, and a managed Postgres instance, the benefit of that is replication is managed. There's a cluster for read and write, and if it goes down, then AWS says that fine, I'll bring it back up. If you're going to accept payments, then you need to integrate certain payment gateway APIs. We use Stripe, Razorpay, and PayPal. The interesting thing here is that if your API call to Razorpay is taking too long, that is okay. Razorpay can come back to you by hitting your webhook. Webhook is like an API that you are exposing. So you're saying accept payment to Razorpay. Razorpay will process the payment and after some time hit an API of your own. It may not give a response to the original request, or it will give a response saying that, okay, fine, I got the request, I will process it later. Here, there are some product issues which can come up. A client who's just made a payment is looking forward to accessing the course, and it may take up to like 3 or 4 minutes for them to get course access, which is not a big deal, but it is possible. Ideally, what you want to do is you want to choose gateways which do this very rarely, and all three of these are quite rare when it comes to delayed payment. Interestingly, if a person is hitting your webhook and saying that the payment is successful, then how do you ensure that this is really Stripe or PayPal sending that payment notification? Because if I'm able to get your webhook, then I can just hit that address and say, Gaurav has purchased the course and all my friends have purchased the course, so like 100 more people. The reason this is a little secure is because you have something called a secret. Stripe gives you a secret saying that, when I talk to you, I have my private key. I'm going to sign this request with my private key, and you can ensure that the person talking to you is Stripe because my public key is published in the world. You can have a look at public-private key at InterviewReady. A lot of the security mechanisms are already covered there. For marketing, we use SES, which is simple emailing service. In fact, we have marketing emails sent through Amazon Pinpoint, which is a service on top of SES. If you're directly sending emails from the server, use SES. If you're going to be sending campaigns or well thought through HTML emails, you can use Pinpoint. All of these services are monitored by CloudWatch. CloudWatch is a service again provided by AWS. What it does is it monitors the health and metrics of these different systems. You can also publish logs on CloudWatch. That's what we do through EC2. And you can set up some sort of alerts also. Like I said, we have simple Slack notifications, but you can, I think, also have SMS and email notifications telling you that something is terribly wrong. So finally, you move from this architecture to this architecture. As a startup founder or as a person working in a small team, you might actually prefer this. I personally would also prefer this, but this complexity brings in some benefits. One is control. You have individual control over each of these components, and if you see that there's something cheaper out there or something better out there, you can just move that component out and bring in a new one. The other thing, like I said, was cost. Cost is significantly lower for these kind of architectures because when you have a managed solution, they charge a premium. But when you have components individually being managed by you, the benefit is you can see how your website behaves and based on that choose the kind of technology that you need. I'll take an example. EC2 instances. Some are intensive in terms of IO, some are intensive in terms of memory. For an edtech website, nearly all the requests you receive are going to be common. Okay, for a social networking website, you have different posts, different comments, different likes for different people. You have to give them different recommendations. So caching is beneficial, but caching is not universally beneficial. For an edtech website, it's pretty much the same content for everyone. So if you can cache all the content and all the comments on that content, very rarely do you need to go and hit your database. So you can have memory intensive machines, which will end up costing you a little lesser than otherwise. Similarly, emails. If you are going to use a service like MailChimp or a service like, let's say, HubSpot, their charges are very, very large, significantly higher than Amazon Pinpoint, which is, in my opinion, as good as MailChimp. I'm not very sure what exactly you need to do with the marketing thing. Of course, you should compare these technologies yourself. But in terms of cost, I don't see anything cheaper than Amazon SES. With that in mind, why don't we just take our payment gateways, get rid of it, and have our own payment gateway? Why don't we build one? That is a problem because the kind of regulation you need over there, the kind of complexity that you bring in, and the security mechanisms for these payment gateways is significant. Having said that though, banks provide payment gateways now to end customers like us. So we might make that decision that why do you need to use a payment gateway for the rest of your life? Directly go and hit the bank. I have seen the rates, it is cheaper and it makes sense. At our scale though, the cost of 10,000 or 20,000 rupees more is not worth the headache that we'll take to migrate from payment gateway to the bank's payment gateway. And so there are 5 main points I want to leave you with. The first one is iterate. Don't do everything together, do it step by step. Improved versions. Second one is work with what you have. You don't need to bring in more technologies. You don't need fancy techie thing to solve a problem. It's possible that you can have a simple piece of technology which is going to scale tremendously, which is up to 1 lakh or 10 lakh users. So you don't need to move. Third, think beyond tech. It's not necessarily that every problem has to be solved technically, that you need a server with an API which is going to automatically find the right solution. It's possible that you do something manually. It's possible that you don't do something. It's possible that you do outsource something. A lot of this is around solving problems, but not necessarily through tech. So you're focused on solving problems, but it's not tech problems that you're looking for. Fourth is estimations. If you're unsure about, is this going to scale? What's going to be the cost like? Isn't this something I should move in-house? Estimate. Estimate for the next 6 months. Don't estimate for the next 5 years because your startup may not exist then. And finally, you have outsource. If you can outsource a problem and it turns out to be cheaper, just do it. Yes, I said things about control. Yes, I said that cost usually is lesser if you bring things in-house. But that doesn't mean that it's always going to be the case. Sometimes when you outsource something, the initial cost is so low compared to you building the solution that it makes sense to just outsource and see what the cost is going to be like. It's easier, cheaper, and maybe a little less lost opportunity if you go for outsourcing your problems at the start. So thank you so much for watching this. This has been a rather detailed video on how startups work when it comes to the tech side of things. If you have any suggestions or would like to discuss this further, I'm in the comments below. You can share your thoughts and opinions. I would love to hear them. Until next time, see you. Bye-bye.